So let us talk about why gate resistors are required. Okay. So gate resistors in case of PMOS or NMOS, both the MOS. So in case of PMOS or NMOS, both we need to understand the concept of gate capacitor. So for MOS or metal oxide semiconductor, there is a formation of capacitor here at this point with oxide, the oxide layer being the insulator in the capacitor. So whenever there is a voltage applied at the gate, whether in case of NMOS or PMOS, in both cases, this capacitor starts charging and charges up to a certain value. So for capacitor charging, the initial current taken from the gate will be quite high, and your voltage obviously will be 0 at first initially. Then it will go, the voltage will gradually increase, and it will be, and when it is equal to the applied gate voltage, it will stop charging, and your capacitor charging current, the current through the capacitor, will start at a very high value, and with time it will fall down to a 0 level. So this is your voltage across the MOS capacitor, and this is your current through the capacitor. But if you can see this graph, this initial current, this value is very high at 0 time. So whoever is controlling the gate, say we are controlling from a logic circuit or say a microcontroller, this microcontroller, whenever this connection is made, this microcontroller has to provide the NMOS this very huge current, and if there is no resistor at this path, then it will as if the current will go from the microcontroller to the source, which is generally connected to the ground in case of NMOS. So that is a very high current drawn from the microcontroller, which can damage the microcontroller. Thus we need a resistor at this point to control the current amount, the initially drawn current amount. So it will obviously, the inclusion of this resistor will increase the charging time, and thus will decrease the switching speed of the MOS. Okay. Another point that is there is that, so this resistor, along with the parasitic inductance and the capacitor of the MOS to the ground, so if your resistor is not there, so you have a circuit only with the inductor and the capacitor. So that is an oscillatory circuit which can generate a ringing at your gate input. So whenever your gate voltage is from on to off, from off to on condition, due to this abrupt change in voltage, this inductor and capacitor, the parasitic inductor and the capacitor can create a ringing at the input voltage, and that can sustain, and this ringing can sustain for a time. When you include the resistor here, this provides a dampening effect. So this ringing gradually dampens out. So if say if there was no resistor, then it will like go on for some time. But with the resistor, the green color with the resistor, it will dampen out in a shorter time. So that is the two reasons. So first reason becoming because of the resistor. The first reason becoming to stop the high initial current being taken from the controlling microcontroller or something to save it, and secondly to stop ringing in the output voltage. Okay.